Hi all, I'm just going to do a very quick, informal chat about this next lesson, lesson 5. I just want to cover one or two things that I may have missed that could have caused confusion in the past. And just to explain one or two things about what's coming up in this lesson, there's a thing called an air bleed that's quite confusing. So I feel it's best if I just explain it to you rather than you reading it and getting lost and not have a real understanding in air bleed. So I'm going to make this video. It shouldn't last long. Hopefully it helps. The lesson is short this week, this lesson. And then on Thursday, obviously, I'll post another lesson which will have a bit more to it. But I'll make a start. You can read through the success criteria and everything yourself. Basically, we're just looking at things called time delays in circuits and different actuator types. But before that, I want to show you this. I thought this was quite interesting. I found this image. If you're thinking about actuators and 3-2 valves, obviously you have the different states in the valves, the exhausts, the airflow, the pilot air, etc. But this image is showing you what happens when you actually push a push button on this valve. So if you push the button down, the state of the valve will change. Okay, so you're probably thinking beforehand, what is all this? These different areas, these different ports, etc. Well, basically, you have two different areas to it. This rectangle or square and this square. At the moment, obviously the airflow is coming back and through the exhaust. However, when you push the button down, imagine this square falling down into this square, okay? And that's what it will end up looking like. So this is falling down into here. Notice this airflow here. When that comes down, that position is now here. And this stopper is down by the exhaust. So nothing can come in the exhaust, nothing's going out the exhaust except the air is now able to flow through, and air flows to the output, whatever that is, whether it's one of the, mine's gone blank, one of the single acting or double acting cylinders, okay? That could be the output, it could be whatever. So when the button is pushed down, it will be here, but as soon as the button is released, then the spring will push this back up into this original state where the air can then flow back through the exhaust and pilot air is then cut off so no air flow can come in. So hopefully this gives you a better idea of what is actually happening in these circuits. So if I go to one of the past papers, National 5 past papers I was looking at, let's have a look. Yeah, it's confusing, but basically here we have just the simple thing that we're looking at with a push button actuator. Again, if you push that, it will fall down, the air can then flow through here. And it doesn't matter what it is that you have as the actuator. This is a microcontroller. As soon as the signal is found, it will then drop down, and again the air can then flow. So it doesn't matter whether it's a foot pedal, whether it's a push button, whether it's a microcontroller, it's all the same. It will have that effect. Okay, it will come down and allow the air to flow. Hopefully that will help make sense of things in the future. Basically, what we're now going to look at is the different time delays. You can read through this in your own time. You can listen to me. You can pause, rewind, go back, whatever you want to do with this lesson. But time delays, it's possible to achieve a time delay in a pneumatic circuit by using two components. You have a unidirectional restrictor and a reservoir. A unidirectional restrictor will let the air flow from the left. It will then go through this small area and then out this side here. It says the bypass path is blocked off, so the air is forced to go through the restricted path. So this is the restricted path here. It's a lot smaller, so not as much air can flow through as normal. This bypass way is blocked by this ball. Nothing can come through, so it all has to go through the restricted path. And this slows the air down to a slow trickle. So this can be used if you want to slow things down, if you want a slower release, if you want more control over something. this unidirectional restrictor is better. But then if anything was to flow back through, then it doesn't need to go through the restricted area. It can come up here, the ball will fall out of that position, and the air can be pushed back out should it want to at normal pace. You can also have a reservoir. This is a small container for compressed air. As air flows in from the left, it will first of all start to fill up the reservoir. Think what a reservoir is normally. It's water that fills up in a big area, and it holds the water and allows it to trickle out over time. And that's the same with the reservoir here. Only once the reservoir is full will the air continue to flow. So the air will trickle in here, it will fill up over time, and it won't flow over here to the right until the reservoir is full. Then the air will come out. So it's like a time delay. Imagine it took a minute for the reservoir to fill up, then you'd have a minute of no air flowing through, and that will buy you time should you want to the rest of the circuit to do whatever it has to do. And it's good when it comes to using circuits. If you're in a factory and you're wanting other things to happen, it will buy you time for the rest of the circuit to do whatever it has to do before it goes back to the start of the operation. So the reservoir, it says here, a complete time delay circuit is shown on the right. Full pressure air flows into the unidirectional restrictor where it is slowed down to a faint trickle of air. This low pressure air then trickles into the reservoir, slowly filling it up. Once the reservoir is full of air, it will continue to flow towards the right. There should be a comma between full and air there. But basically, this is a full time delay circuit. If you're wanting to really slow down the air, it will be done through the unidirectional restrictor here. And then you have the time delay of the reservoir. So this is extremely useful if you're really wanting to slow down the air flow. And that could be for safety reasons or whatever it is that you're needing this slow air. It says time delay circuits are often placed in the pilot air line of a 5-2 valve to delay the movement of a piston, to slow the piston down. Okay, so well, hopefully once we're back at school, I can actually show you this sort of stuff using the pneumatic equipment that we have with a proper, with all the stuff that you actually see it in motion, and we'll have a full circuit going, and you can build it and you can actually watch it go. Fingers crossed, if and when we get back to school. Just don't know when that will be, unfortunately. But hopefully that makes sense. These are all just here to slow the air down, okay? Whether it's the uni or the restrictor or the reservoir, it's to slow the air down. The next thing is an air bleed, and the air bleed is quite confusing. Just looking at the pictures and reading it, it doesn't really make sense. So that's why I've made this video, primarily for the air bleed's reason, to explain what is going on. It's basically an actuator, the air bleeds. And it can work in two different ways. Basically, what it's saying is an air bleed is simply an open pipe that allows the air in the circuit to escape. If you think of this as the pilot air coming in, it's restricted, it comes through, can then go this way or this way. It's going to go this way because this wee bit here is just an open pipe, and it allows the air in the circuit to escape. This air must be at a low pressure, otherwise the pipe would wave about and be dangerous. If you think of fire hoses, if you don't hold onto a fire hose when there's a lot of pressure going through it, a lot of water, if it's not being held onto, it'll flap about like in the cartoons. It's the same with this pipe. If there's too much pressure and air coming out, it'll start flapping about. It can be dangerous, hit you in the eye. You don't want that. So it says this air must be at a low pressure. Okay, so it should be at a low pressure. Air bleed circuits rely on a component called the diaphragm valve. So this is the diaphragm here. And this valve is capable of detecting small changes in air pressure. The valve works in the same way as other 3-2 valves. It is only the actuator that is new. So again, that square will come down here, allow air to go through, and vice versa with the spring. However, instead of it being a button or whatever, it is this air bleed. So if you block the air coming out of the bleed here, then the air can come back up into the diaphragm and this expands here. Okay, it expands. And then the air can come through. If it's blocked and the pipe, this pipe that will wave about, can't wave about, can't let the air out, then a lot of the air will then just simply go straight on and through and out this way. So it's used in factories. Say, one of the examples in an SQA pass paper is a factory that is making pastries. And as soon as the pastry comes in, I'll show you. Hopefully it will make sense here. So no, that's a saw. It's not quite the same, that example. Let's see if I can find it very, very quickly. Okay, this is the one. Portions of the pastry travel along conveyor belt. And basically, when the pastry is sensed, it'll be pushed into a wee container. And the pastry blocks the air bleed. It will then allow the air to come through and push this cylinder, or push the pastry away. And that's what it's for. Is the air bleed can be blocked, and then it will allow the next part of the circuit to run because of the pressure. So that's one way it will work. The other way it will work is, it says, I'll just read it. So this here is explaining what I've just mentioned. When the air bleed is blocked, air is diverted back towards the diaphragm. This actuates the T2 valve and the cylinder outstrokes. So blocked off there. The air comes back through, any excess air up into the diaphragm, but it should go through here and push this out. Okay. It then says the diaphragm is a piece of rubber stretched inside the valve. When air flows into the top of the valve, so the diaphragm's a piece of rubber, and it's like a balloon. It will stretch if air comes into it. It says when air flows into the top of the valve, the rubber expands much in the same way as a balloon is blown up. When the diaphragm expands, it presses down inside the valve and it changes its state. So as this diaphragm expands, it pushes down and causes this the air to then be allowed to flow through. Okay, so the air bleed can either work by the air bleeding out, being blocked, pushing the air through, or the air coming in, the diaphragm expanding and then pushing down and causing the state of this to change and allow the air through. Okay, so there's two different ways that this air bleed diaphragm valve can work. Okay, so as I said, it's an actuator, and that's basically it. If you have any questions, please do ask. I've not finished the questions here, so there's no point in me showing you them. It's to do with this lesson, but I hope that gives you a better understanding of what is going on. You can play the video back, see it again. If you're still not 100% sure, I can try and explain it to you again. I've looked through YouTube. I've tried looking for lots of different ways of showing you a proper air bleed in practice, but for some reason it's showing me only aircraft air bleeds, which are not quite the same, and there's a lot more science behind them. When we get back to school, I should be able to show you the proper thing in practice, excuse me, which should allow it to make more sense. But at the moment, you just need to know there's two states that can actuate the valve. That's when the air bleed is blocked, or when the diaphragm fills up and pushes down and actuates the valve. Okay, hopefully that helps. Any questions, let me know, and I'll speak to you soon. Okay, bye-bye.